previous session we have discussed about transistor. Transistor means transfer the signal from low resistance side to high resistance side. Okay, so it can be mainly classified into two types, BJT and FET. BJT means bipolar junction transistor. FET is nothing but field effect transistor. So BJT operates both majority and minority carriers, though only the name suggests that bipolar junction transistor. But in case of FET, it only depends upon majority carriers, so it under the category of unijunction. First of all, we have discussed about BJT. So BJT, it's having 3 terminal and 2 junctions. So the 3 terminals named as emitter, base and collector. Okay. So emitter means it emits the current flow towards the collector with the help of base. It is very heavily doped, and then base. Base is very lightly doped. It separates between emitter and collector. It can just transfer the current from emitter to collector. And third terminal is called as collector. Collector is moderately doped. It receives the current from emitter with the help of base. And its 2 junctions can be available. One is the emitter base junction and second one is collector base junction. Okay. So this is the structure diagram for transistor. It's made up of either PNP or otherwise NPN. So the 3 terminal is named as emitter, base and collector. So this is for one junction, this is for another junction. This junction is called as emitter base junction and another junction, this junction is called as base collector junction. Okay. So next we have discussed about operation of BJT. First, we have discussed about the symbol and structure. Okay. So, symbol wise, it can be represent emitter current flow. Okay. So, the emitter current flow towards the junction is called as PNP transistor. This is for base and this one is emitter and another terminal is called as collector. This is for PNP because the emitter current flow towards the junction is called as PNP transistor. And then next one, PNP transistor. PNP transistor means the emitter current flow away from the junction is called as NPN transistor. Okay. So it's mainly classified into 3 types. 3 configurations can be available in transistor. So first one is common base configuration. Second one is common emitter and third one is common collector configuration. Common base configuration means base is common for both emitter and collector, and second one is common emitter configuration means emitter is common for both base and collector, and third one is common collector. This is for collector is common for both base and emitter. Okay. So first one, common emitter configuration. So common emitter configuration, this is the circuit diagram for common emitter configuration. So we can choose either PNP or NPN. So you have to connect supply with base and emitter. The voltage supply is named as voltage between base and emitter. So positive supply is given for base and negative supply is given for emitter. And then output side, so you have to put another one voltage supply, that is the output supply. So it is named as VEC. So VEC stands for voltage between emitter and collector. Okay. So this is the general circuit diagram for common emitter configuration. So here we have to plot the graph between input characteristics as well as the output characteristics. First of all, how to draw the characteristic curve for input. Okay. So BJT is nothing but it is a current control device. Why it is called as current control device means the output voltage can be controlled with the help of input current. So only it is called as current control device. Okay. So first we have discussed about input characteristics. So input characteristics you have to identify with the help of output voltage and output current. Output current is IC. The input current is named as base current IB. So you have to plot the graph between output voltage. Output voltage here VEC and then output current IC, and it can be vary with input current IB. So and then output characteristics. So next we have discussed about you have to plot the graph for output characteristics. So the output characteristic we have to plot the graph between VBE and IB, and VEC is kept at constant. So then we have to draw the graph for input characteristics and output characteristics. First I am going to draw the graph for input characteristics. VEC versus IC. So milliampere, it is in terms of millivolt. We have to plot the graph for various values for IB. So IB very small amount of voltage, so it can be mentioned as microampere. So in BJT, three regions can be available. One is the active region, and second one is cutoff region, and third one is saturation region. So the voltage is increased but current is zero. This portion is called as cutoff region, and both current and voltage increased. This portion is called as active region. And then voltage can be increased but current contain constant. This region is called as saturation region. Okay. So the mostly the transistor can be act as the amplifier in the active region. Active region means both emitter, two junctions, you already know that two junctions can be available. One is the emitter base junction, another one is collector base junction. The two junctions can be in forward bias. The transistor can be act as the active region, and both emitter base junction and collector base junction, both junction can be reverse bias. It can be act as a cutoff region. In saturation region, both emitter base junction and collector base junction both forward bias. Okay. So once again I am going to explain. Active region means emitter base junction is forward bias and collector base junction is reverse bias. It is called as active region. Cutoff region means both emitter base junction, collector base junction can be act as a reverse bias. And then saturation region, both the junction can be act as a forward bias. Okay, it's clear? And then next we have discussed about output characteristics of common emitter configuration. So in case of output characteristics, how to plot the graph between VBE versus IB. Okay. So the width VCE is kept at constant. 0 volt, 1 volt and then 2 volt. Okay. So this is for output characteristic for common emitter configuration. And then next move on to the current amplification factor for common emitter configuration. So the current amplification notation for common emitter configuration is beta. So this is nothing but the variation of output current by input current. Here the output current is collector current and the input current is base current. So therefore current amplification factor for common emitter configuration beta equal to del IC divided by del IB. Okay. And then next one, move on to the common base configuration. So in case of common base configuration, base is common for both emitter and collector. Okay, so this is for base terminal, this one is emitter and this one is collector. So the base terminal is common for both emitter and base. So you have to give the supply for input supply for emitter and base. This supply is named as VBE, voltage between base and emitter. The corresponding input current is emitter current, it is called as IE. And then output side, so the supply is named as, output supply is named as VBC, that is the voltage between base and collector, and then the corresponding output current is called as IC, collector current. Okay. So here also I have to draw the graph between input characteristics and then output characteristics. First I have to discuss about input characteristics. Input characteristics means you have to plot the graph between input voltage versus input current and then output voltage is kept at constant. So you have to draw the graph between VBE versus IE and then VBC is kept at constant. Okay. So and then we have to discuss about output characteristics. So in case of output characteristics, you have to draw the graph between output voltage versus output current. In input current is kept at constant because it is a current controlled device. Output can be controlled with the help of input current. So IE current is kept at constant. So you have to draw the graph between VBC versus IC and IE is kept at constant. So this is for output characteristic for common base configuration. And then next one, current amplification factor. So the current amplification factor notation for common base configuration is alpha. Alpha is output current, the variation of output current by input current. So therefore input current is common emitter current and input current is output current is common collector. So del IC divided by del IE. This is the current amplification factor for common base configuration. The alpha range is 0.9 to 1 in type 2.